Hello, we're going to do another measurement lesson. This is Unit 14 measurement, measurement 8-16, surface area of prisms. And that is in the title right here. This is found in your Jump Math workbook on page 161 to 163. So this is a little bit of a longer lesson, but a lot of it is diagrams, so I think we'll be just fine. Taking a look at question 1, it says pictures are not drawn to scale. Number 1, in each prism, shade all the edges that have the same length as the edge marked. And they have one here as an example for us. So they've marked one edge here, and that's 1 centimeter. Now, because we know this is a prism, and the base and the height are the same, top face and bottom face, then all of the four four edge vertices, not vertices, four edges are going to have the same length. We can do the same thing with B. If this one here is marked as 2 centimeters, then this one is going to be 2 centimeters. The back one's going to be 2 centimeters, and the back top is going to be 2 centimeters as well. Go ahead and do the same for C and D. Just mark the edges that have the same length. Number 2 says find the missing edge for the length of the prism. We're going to do the exact same thing as we were doing before. They've added in some extra information to try to confuse us, but again, we're just looking for the same edge. Now, this one here is 1 centimeter. I'm also looking at this one here and this one here. These are all going to be the same length, so those are all 1 centimeter. Okay, so I'm doing exactly what I was doing up here. I'm just finding equal edges here. Okay, and this one here, I'm looking for this length here. So that's this one here, which is going to be equivalent to the back edge. And that's going to be 3 centimeters. Okay, go ahead and do the same thing for C, and then we'll move on to the next one. Number 3, it says, shade the face that has the same area as the shaded face. Oh, I like this one. This one sounds pretty good. I'm going to change my pen color to green. Now, if I'm going to shade the face that has the same area, well, I'm assuming that's the front face that we're looking at. And so I know the front and the back face are going to have the exact same area. So I'll shade in the back face. Okay. And this one here, this is the front face, and I will shade in the back face. What do you notice about the face that has the same area as the one that's shaded? Well, they're opposite to each other, aren't they? So go ahead and do question C on your own. You do this one here. Let's take a look at number 4. The area of each visible face is given. What's the area of the hidden face? So now they're saying, just like the question above, if we know one of the faces, the visible face, we can find the area of the hidden face as well. So if I take a look at the back face, the back is hidden from me right here. The back is going to be somewhere under there. It's going to look something like this, okay? And I know the area of the back is going to be equal to the area of front. So the back is going to be 6 centimeters squared, because those are opposite, front and back. The area of the bottom is going to be equal to the area of the top. So that's 12 centimeters squared. And the area of the left, which is also hidden, is going to be equal to the area of the right, because they're opposite. And that's going to be 8 centimeters squared. Okay? You can apply the same technique to do B and C. You're just looking at the opposite, and the opposites are going to be equal. Number 5. Whoops, put my camera on there. I don't need that. Number 5 says, write the area of each visible face directly on the face. Then double each area to find the total area double each area to find the total area of each pair of congruent faces. Okay, so let's follow the directions. We're going to write the area of each visible face directly on it. And the front is done for us. It's 6 centimeters squared, and they got that by multiplying the length times the width. So the top is going to be 5 by 3, so that's going to be 15 centimeters squared. And the right is it's 2 by 5, so that's 10 centimeters squared. So now we've done this part here. We wrote the area directly on the face. Now we can find out what each one is. Front and back together is 6 times 2, so that's 12. Top and bottom is going to be 15 centimeters squared times 2. And so that's 30 centimeters squared. And we are left with the right and the left. And they were 10 centimeters squared. And there's 2 of them. That's 20 centimeters squared for those ones there. It's not asking us to find the total area of the entire shape, but we could do that as well. We just have to add up these ones here. So we go 12 plus 30 plus 20 equals 2. 1 plus 3 is 4, plus 2 is 6. 62 centimeters squared. That's the area of the entire shape. But I think we're probably getting there on the next question. Let's check it out. Number 6, the surface area, well, let's read the gray box here. The surface area of a 3D shape is the total area of all the faces of the shape. Okay, so whenever they're talking about surface area, what they mean is if you were to flatten this out, like it was a box and you were to take it apart, you would measure each face and you would be able to find out what the surface area is. So let's take a look then at this one here. Calculate the surface area of the prism. To find the surface area of the prism, I would find the area of all the faces. Okay, so I'm going to start with the front, and the front is 2 by 1, so that's 2 centimeters squared. The top is 2 by 3, so that's 6 centimeters squared, and this one is 3 centimeters squared. To find the surface area of the entire shape, I just have to say, well, the top is the same as the bottom, the front and the back are the same, and the left and the right are the same. So I've got 6 times 2, 3 times 2, 2 times 2. So that is 12, 6, and 4. I'm going to add these all together. That is a total of 22 centimeters squared. That's the total surface area of that entire prism. Okay, we're going to work through one more here. Again, I'm going to find the surface area of the front, and it's 2 by 3. So the front is 6 meters squared. The top is 3 by 4, so that's 12 meters squared. And the left side is 4 by 2, so it is 8 meters squared. Once I have those, I can say, because I know the front, I know the back. So I've got 6 meters squared, and it's times 2 because there's a front and a back. I can say it because I know the top, I know the bottom, so that's 12 meters squared times 2. And if I know the left, I also know the right. 8 meters squared times 2, 16. To find the total surface area, I have to add all of the faces together. So I'm going to add these together. 2 plus 4 is 6, plus 6 more is 12. I'll carry over to the tens. 1 plus 1 is 2, 4, 5. The total is 52 meters squared. Go ahead and do C on your own. That's your extra practice. And then we'll take a look at the next question. Whoops, we've gone too far. Number 7 says, Mickey calculates the surface area of the prism to be 40 centimeters squared. What did she do wrong? So you're going to solve this one on your own, find out what Mickey did wrong, okay? And the only way you can find out what she did wrong is by doing it the right way and then working backwards from there. So find the surface area of that prism. Let's take a look at 8 after you do that one. Alexandra says that she needs to find the area of only 2 faces of the prism to calculate the surface area. Is she correct? Explain. Well, let's take a look at this surface area. It's 8 by 5, so that is 40. This is also 40. And then, whoops, no, that's 8 by 8. Where's my eraser? That shouldn't be 40. That should be 8 times 8 is 64. And then this one here is 5 by 8, so this is 40 as well. Now, can she figure out the surface area with only 2 faces? Yes. Yes, she can. Because she knows that because the measurements of this is a square, then she's actually just multiplying the side faces by 4. There's 4 side faces and a top and a bottom. Now I'd like you to do the second part. I'd like you to actually find the surface area of this prism. Go ahead and do that one. Let's take a look at number 9. It says, write the name of each face of the prism on the net, then mark the length of each edge on the net. Okay, so we first have to label them. And they've given us the right one. Okay, so beside the right is the front. And on the other side is going to be the left. We've got the bottom, the top, and the back. So those are the parts that make up that prism if I were to unfold it. The next step is to, I'm just going to change my color here. The next step is to write the measurements as they have done here with this here. So the right side, they said, is 1 by 4, which means the left side is also 1 by 4. Okay? It means that the bottom and the top are going to be the same, and they are 3 by 4. So that's 4, that's 3. Oops, that's not 3, that's 4. And the back is the same as the front, which is 1, and it is 3 across. Okay, so that's how we do that one. We have to label it, and then we have to put the measurements on there. I'd like you to do the same thing for the triangular prism in B and for the triangular prism in C. Okay? After you've done that, move on to the next question. Number 10 says, find the surface area of each prism from question 9. Include the units. Okay, so this one here, we're going to do, I'll do A with you, and then you can do B and C on your own. So let's try to find the surface area of the rectangular prism we had at the top. Okay, so just like we had before, we're just going to find the area of the front and double it, because the front and back are the same. Let's find the area of the top and the bottom, and the left and the right. Okay, so first off, let's do the left and the right. So the right is 1 by 4, so it is 4 centimeters squared times 2. That's the front, or sorry, that's the left and the right. The bottom and the top are the same, so they are 4 by 3, which is 12 centimeters squared. And there's a top and a bottom. So it's 24 centimeters squared. And front and back, they are 3 centimeters squared. That's 1 by 3. And there's a front and a back. So there's 6 centimeters squared there. Let's add them all together. 24 plus 6 is 30. 30 plus 8 is 38 centimeters squared. Okay, that's how we find the area. So now you're going to do question B and question C. Find the area for B and C using your measurements from above. Let's take a look at the final question they ask us there. And the final question is, how is the surface area of a prism related to the area of its net? And the surface area is equal to the area of the net. This is where it ties into what we were doing at the beginning of the unit, where we actually built the nets of the three-dimensional shapes. If you take a three-dimensional prism and you unfold it into a net, that is equal to the surface area. It's all of the surfaces added together. Let's check out the next page. We're on page 163 now. Page 163, question 11, they say, find the missing length. Well, we're working backwards now, and they give us the area, and we know area equals length times width. So they're saying 12 is equal to 3 times something. Well, what number is that something going to be? 3 times 4 is 12, so the area is 4 by 3. Okay, so that's what we're doing. We're doing some basic algebra to work backwards, finding the missing dimension, the length or the width, from the area. Go ahead and do the same thing with B and C. Take a look at 12. Find the missing edge length. Okay, so they have given us, if I look correctly here, they've given us the missing edge we need to find. Oh, they've given us the area of one face. Okay, they've given us the area of the right face. And we have the area there, and I know that the height is 4. Okay, and that means the height and the length and the width of this is multiplied to make 20. 4 times 5 is 20. Okay, the 6 doesn't matter. I don't need that one for this one here, 6 meters. But to find the right side, it's going to be 4 meters times 5 meters. Let's take a look at B. They've given us the right face again, and it's 15. The height is 3. So the other side must be 5. 3 times 5 is 15. That is a shockingly bad 5. Okay, 5 meters. Go ahead and do the same thing for C. Let's take a look now at number 13. Number 13 says edges A, B, and C have lengths that are whole numbers. The surface area of each face is written directly on the face. What are some possible lengths for A, B, and C? Hint, why can edge A not be 4 meters long? Okay, so we know that A is not 4 meters long. So let's kind of put in A, B, and C. And we know that they're whole numbers, so there's no decimals here at all. And I need numbers that are going to multiply to make 18, 12, and 6. Okay? I'm guessing that it can't be 4 because 4 goes into 12. It's a factor of 4, but 4 is not a factor of 18, and A is shared between them. So what other factors for 12 and 18 do we have? Well, we've got 2, 3, 6. Let's try 6. So if we said A was 6 meters, then looking at the top, 18 divided by 6 would mean B would be 3 meters. Okay? And then if A were 6 meters, then C would be 12 divided by 6, which would be 2 meters. Does that work out for all the other faces? To get this face here, I have B times C, which is 3 times 2. Yeah, that works out. And to get 12 meters squared, I would have A times C, which is 6 times 2. Yeah, these dimensions work out. Okay? Remember, volume equals, oh, what am I doing? Volume isn't part of this one here. Ignore that. Having a moment. Surface area equals length times width. And when we're looking at a net, we're looking at all of the faces, and they're just, each face is length times width. Okay? Number 14. We're going to skip 14. I don't like that one. Calculate the surface area of the prism. Be careful with the units. And they're saying be careful with the units because this is in meters, but these two here are centimeters. So you're going to have to convert. We did one like that on the previous page. Okay? So I want you to give that one a try. Do that one here. Number 16. It costs 40 cents per square meter to paint a room. How much would it cost to paint the walls of this room, not including the doors and the windows? Ooh, this one looks like a good one too. This one's a little bit more challenging. This is like something you would probably likely see on the provincial achievement test. It's a multi-step problem. So let's break it into steps. First off, we need to find the surface area of the prism. Oh, that's a tough one. They're not really saying we need to do the roof or the floor. So what's the surface area of the walls? All 4 walls. Okay? Once you found the surface area of the walls, you're going to need to subtract the surface area of the windows and the door. And that will give you how much paint you need. Now you're going to have to take the total number of square meters And we're going to have to thirdly find out the total cost. So we'll have to multiply the square meters by 40 cents per meter squared. Okay. I know I could have done this question for you, but I'd like you to have the joy of being the problem solver on your own. We're going to ignore 17 and 18, so I want you to go ahead and do all of these. Again, like the previous lesson, I will try to upload the answer key for you, and that will help you immensely with the solving of this one.